Okay, so with this here, we need to show that when you take one logarithm away from the other, it can be written as a single logarithm with the terms divided. Okay, so very similar to the one we did previously on adding. Okay, you simply learn the approach. So again, you let log to the base a of x equals to m. So therefore, because m is the power, a is the base, you swing the base and it gets rid of the logarithm. So you get x equals a to the power m. Also, we do the same for the other one. Okay, let the logarithm equals to n. So we'll swing the base there. Okay, and obviously n is the power. So we have y equals then a to the n. Okay, now look what it's going to achieve, x divided by y, right? Okay, so that's what we're going to look at there, what x divided by y is. Now, of course, x we've got as a to the power m, and y we've got as a to the power n. And what I want you to realize then is, when you're dividing, okay, the same terms, the rules of indices here, we just take away the powers, don't we? So in this case, it'll be m minus n, because it's dividing there. You take away the powers using what we learned about rule of indices. So I've got this set up, and what I can do is I can write this as a logarithm, because I've got the base a to the power m minus n. So I can get my logarithm equal to the power. Okay, all I need to do is think about swinging that base over to create the logarithm. So log of log the base a of x over y will then equal my power, which I'm left as m minus n. And then to finish off, of course, because we know m is log to the base a of x and n is log to the base a of y, we've got the solution. Okay, that's true, always true. As you've got there, take one log away from the other, it's the same as a single log with the terms divided. Okay, so part B then, okay, it says here express, right? In part B, express this as a single logarithm. So I'll write it out to start with so we can see what it is. We're going to take our time on this. So it's not an equation, okay? In a sense, it's like an expression, isn't it? Okay, because if it was an equation, we'd have like equals to something. But we want to express it as a single logarithm, okay, using the rules that we know of logarithms. Now, one of the rules we use, the third law, isn't it, is if there's a number in front, we can take it up as a power, okay? But we have to be careful here. So log to the base b, if I take that third up, okay, and it becomes a power, it becomes a power of all of this, okay? Because if you look here, we've already got a power, haven't we? We've got x to the power 15. It's already a power. But when you take that number, or whatever it is, fraction here, up, it becomes a power of all of this. So what I would do is I'd write this as in a bracket, and then put the power there, okay, like that, to show that that third is a power to all of it. And the next one, there's nothing really I need to do. And then this one, again, I need to take that 4 up, okay, make it a power, but remember I need to make it a power of all of it. So you've guessed it, we need to put a bracket there and then put to the power 4, okay? And then we get something interesting. You've got power here raised to a power, you've got two powers, but when you've got one power raised to another, you times them. So this will become 15 times a third is 5, yeah? 15 times a third is 5, so you times them. This stays as 27x there. And then here we can work this out. 3 to the power 4 is 81. X to the power 4 there. So you've got to put everything to the power 4 there. Okay, almost there. Let's use now the law which we proved in part A. Taken away, okay, these two logarithms here. So let's deal with this first. Let's not worry about this. We'll deal with this after. We'll put it together with this later on. Let's put these two together first. Taken away. So the rule that we learnt in part A was when you take away, you divide. Okay? So you get that. So it'll be x to the power 5 divided by 27 over x, 27x. So I'm putting that as a single logarithm. When you're taking away, of course, you're dividing the terms. plus then the other logarithm. Okay, now this will simplify down. X to the power 5 over 27 to the x, 27x, sorry. X to the 5 over x will simplify then to be x to the 4 over 27, yeah? Okay, that x will cancel with that to make it a 4. Finally, with this here, when you're adding these logarithms, remember when you're adding logarithms, you times the terms, yeah? Adding logarithms, you can put it as a single logarithm timesing the terms. So x 4 over 27 times 81 over x to the power 4. And notice nicely then, the x to the power 4s will cancel. So you get 81 over 27, which turns out to be 3. 81 divided by 7 is 3. So we've got expressed as a single logarithm, and it's just log to base b of 3.